So stay with me on this. Any of these 12 words that you want me to make sure I include or talk about or go in depth on?
Can we talk about indefinite versus definite?
Yeah. Indefinite versus definite, absolutely. And I heard a bunch of people struggling over the fundamental theorem of calculus, so I'll make sure I include that one in my conversations too. All right. Kiara, this is an indefinite integral because I have no upper lower bounds. This is a definite integral because I have an upper lower bounds. And in order to solve that, I'll use the fundamental theorem of calculus to solve the definite. So let's start with my indefinite. So we don't know how to do this unless I do u substitution. And we're only going to use u substitution when I have no other option. So instead what I'm going to do, so remember we talked about coming up with instances where I can look for ways to simplify. If I call this x to the 1/2 power, x squared x plus 1 dx, I can use the distributive property. And I can go ahead in terms of 2, this is 4/2. So this becomes x to the 5/2 power minus x to the 3/2 power plus x to the 1/2 power. I know it's my rate because it's inside of my integral and it's asking me to integrate. And when you integrate the rate, you're going back up to your original function in terms of x. So the rule is your x power goes to the 1 more power. So 5/2 plus 2/2 is 7/2. And then you divide by that exponent. Instead of dividing by 7/2, that's the same as multiplying by 2/7. Now I've done enough of these that I'm used to that pattern. If you're watching me do this for the first time, you're like, wait, what is she doing? But when we did this piece by piece, slow by slow, when you divide by 7/2, you multiply by the inverse, and that's how it ends up with 2/7. When I'm adding 1/2 to x, when I'm multiplying exponents, same base, you add those exponents. I rewrite 2 as 4/2, and that's where that 5/2 came from. Does that sound okay? Everybody know now where all those numbers came from? So I'm going to do the same thing over here. My x goes to the 1 more power, and then instead of dividing by 5/2, I'm going to multiply by 2/5. My x goes to the 1 more power, and then I end up multiplying by that. It's an indefinite integral. I don't know where this integral sits on the coordinate plane, so I need to add a plus c. Now, if somebody told me an xy ordered pair of the original function, which is this, I can plug in an x and a y and solve for my c. So that's that one extra step that might be coming your way. What questions do you have about that indefinite integral? So this one's going to be more of the same. I'm going to rewrite this as 2x to the 5th minus 4x squared plus 7x minus 1 plus x to the negative 1. Once I rewrite that, then it's just those same integral rules throughout. This 2 hangs out, this x goes to the 1 more power, and my new exponent. Now, of course, I'm going to be able to simplify that when the time comes. He hangs out, he goes 1 more, divide by the exponent. He hangs out, he comes 1 more, divide by the new exponent. X to the 0, 1 more is x to the 1. There's no need to do anything else to that one, it's all 1s. And then this, of course, becomes to the 1 more power becomes, x of 0. Uh-oh, divide by 0. Can I do this?
Well, isn't x to the 0 just 1?
So look on the back. What do I do when I have 1 over x? Look at the derivative rules and go backwards. What does it become? There's my ln of x. So if I want to rewrite this, I can say it's 1/3 x to the 6th minus 4/3 x cubed plus 7/2 x squared minus x plus the natural log of x plus c. Okay, so what I'd like you to do now is take a look at what we just talked about, and you find 2 terms from the 12 above that describe what it is that we're doing and share them with your group. Go. All right, so now we move on, and now we notice that we have an upper and a lower boundary. So what I'm doing is I'm asking you to calculate the area under this curve between these two. This is a definite integral because I have a lower and an upper boundary. So when I go to calculate it and integrate it, my x goes to the 1 more power. This 3 hangs out, my x goes to the 1 more power. And I'm not going to bother with my plus c because this next part is when I figure out that area under the curve with those boundaries. So this is the notation that I use. I draw a straight line, and I'm talking about it from 1 to 2. Now it's time to go dipping into the fundamental theorem of calculus. And what that says is this here is my capital letter f of x. This here is my derivative of that, my lower case f of x. So what I'm going to do is find f of b minus f of a. So I'm going to go ahead and plug 2 in first. So that's 2 cubed over 3 minus 3 times 2. That's my f of b minus, and my f of a is going to be 1 cubed over 3 minus 3. So when I go to calculate this, I have, what's this, 8/3 minus 6 minus negative 1/3 minus 3. I'm going to do everything on the calculator because that's what's easier. 8 divided by 3 minus 6. I hate when that happens. 8 divided by 3 minus 6. And then that's going to be minus parentheses 1 divided by 3 minus 3. Math, frac, enter. Negative 2/3. Same thing here, I'm going to rewrite this as 3 times x to the 1/2 power, and I'm integrating it from 1 to 4. So this 3 hangs out, this x goes to the 1 more power, and it's going to be divided by 3/2, which is the same as multiplying it by 2 over 3. And I need to do this math from 1 to 4. My 3's cancel out, which is going to give me 2x to the 3/2 power from 1 to 4. So my f of b is 2 times 4 to the 3/2 power minus 2 times 1 to the 3/2 power. Take the square root first. Square root of 4 is 2. 2 cubed is 8. 2 times 8 is 16. Minus 2, your answer here is 14. That's an accumulation function. So whatever your original function was, that's that output at that place. That's that accumulation between those two boundaries. So whatever your output was originally measuring, whether it was miles, hot dogs, people, that's the output. Turn to your group mates and talk about 2 terms. Go. What 2 terms from the top? All right, so the rest of these, the entire back is what we learned last class, which was U substitution. So at our introductory baby level, they're designed to work out. At our levels, they're designed to work out. So what we need to look for is that function within a function. And we're going to let U equal whatever that function is inside. And we're not going to be worried about things that we don't know how to deal with, because to be honest with you, they kind of work out anyway. So I'm going to rewrite this function as U to the 1/2 power, and I'm going to let U equal to 1 plus x squared. So what I did was I took this function within this square root function, and I just pulled it out because it's easier to talk about U's. My biggest problem here is I've got a hodgepodgey mix of variables. I've got x's, I've got u's, and I've got dx's. So two things are going to happen. I can't integrate u unless I'm talking about with respect to u. So I'm going to have to take the derivative of this to figure out what du dx is. Okay? And then if you're worried about this x, don't be. Because typically when I integrate this, can you see ahead once I take the integral of this, it's going to be 2x? Look, that's going to end up canceling out. So if you're worried about what's going on with that 2x, just hang on. Because like I said, at the introductory level, these are designed to work out pretty cool. So come over here and let's figure out what du with respect to x is equal to. Derivative of a constant is 0. Derivative of x squared is 2x. You okay with that? I need to substitute in for dx. If it's easier for you to rewrite this as a proportion, do cross products and solve for dx. You'll find out that dx is going to be equal to du divided by 2x. This is now what I'm going to substitute in for dx. And it solves both problems in one fell swoop. Because remember I was worried about the x's when I have u's? Nuh-uh, because now I'm going to substitute u's in for x's. Problem 1, gone. And remember I didn't know what to do with this 2x? Look who's down here in the denominator. Problem 2. Gone. So these are designed to work out. So when you do this derivative here, to be able to accommodate this, chances are it's going to help clean up whatever mess you have here. So we can go ahead and substitute. I want the integral of 2x times u to the 1/2 power, and instead of dx, I'm going to write in du 2x. See you later, Sally. Now if I need to integrate u to the 1/2 power with respect to u, I can do that. I know those rules because this now works. It's a rate in terms of u. So I'm going to take my u to the 1 more power, and I'm going to divide by that new exponent. Instead of dividing by 3/2, I'm going to multiply by 2/3. Don't forget your plus c. But wait, there's more. What did I just do? Yeah. So instead of u, I went back and got what u is equal to, and I plugged it in. So that's, which one is that? Definite or an indefinite integral? Indefinite, because I don't know my upper and lower bounds. Now, if somebody gave them to me, okay, then I could do my fundamental theorem of calculus, f of b minus f of a, no problem, and then I don't have to worry about c. And if somebody said, no, I want you to write the specific equation, here's an xy ordered pair that I know works, I can substitute that in and solve for c. What's the matter, Brady? What did you wrong?
Okay.
All right. Ready? I'm going to let this x cubed hang out for a little bit because he's freaking me out. I'm going to go ahead and I'm going to find the cosine of u dx. And I'm going to let u equal x to the fourth plus 2. Can you already see how it's going to work out for you? Take the derivative of u du dx is equal to 3x to the third. Dx is going to be equal to du divided by 3x to the third. Everybody okay with that math? Ah. 4. Thank you. You can put a Smarty up. All right, so I want the integral of x cubed cosine of u, and instead of dx, I'm going to write du over 4x cubed. See you later, Sally. When I go to find the integral of cosine, that takes me back to the sine of u. I have this 1/4 hanging out, and then my plus c. 1/4 times the sine of x to the fourth plus 2 plus c. Talk to your group mates about 2 terms from the front that you can talk about what we just did. Mark said go.